We are used to hearing about many interesting objects in our universe: stars, planets, galaxies, molecular clouds, neutron stars, etc. But there is one kind of object that we are still not sure how to classify it. I am talking about the brown dwarfs. The study of these objects exploded with the availability of new and powerful telescopes capable of observing infrared light, where the brown dwarfs emit all their light. Yet, these still are intriguing objects that scientists study within two fields of astronomy: star formation and extrasolar planets. The reason being that brown dwarfs don't seem to be either one or the other, but rather fall in a gray area between the two categories. From observations, astronomers know that brown dwarfs can be classified according to their temperature in three types: L, T, or Y. Brown dwarfs type L are the hottest, with temperatures that compare to that of a hot pottery kiln. Type T are in the middle and have temperatures close to lava flows. Finally, type Y are the coldest, with temperatures between a hot oven and a cold day in the North Pole. When talking about their masses, we compare them to the mass of Jupiter. This because these objects can have masses between 13 and 18 times the mass of Jupiter, and within these masses, even the most massive of them does not have enough mass to squeeze the material in their core and make it reach temperatures that are high enough to eventually ignite the nuclear fusion of hydrogen or other material and then become a star. For reference, the smallest star where hydrogen fusion is still possible occurs at more than 80 times the mass of Jupiter, or 8% the mass of the Sun. However, within the brown dwarf's range of masses, limited fusion is still possible using a rare form of hydrogen called deuterium. Below this point, even deuterium fusion ceases and we call the object a planet. So does it make it a star? Well, we also question the term planet because brown dwarfs are mostly alone in the sky and not associated with another star. However, astronomers have found that some planets do not orbit around stars and live almost in complete darkness between stars. They call them rogue planets, and they're usually found near star clusters. This is why some scientists believe that these rogue planets might have formed at the same time that the stars in these young clusters, and then are still hot and visible in the infrared. With time and without a star near them, these rogue planets will cool down and fall out of detection. Although there are brown dwarfs that have companions, most seem to be alone. Astronomers have several theories to explain why. One theory states that these are rogue planets created around a star in a normal planetary system, but later they were ejected due to some strong gravitational or violent gravitational interaction. Another theory tells that those stars forming as stars, but they cannot gather enough mass to become one. There are more complex theories to explain this, but none of them are confirmed, so astronomers continue investigating. But there are many interesting things that we have learned about them with observations made by the infrared channel on board of the Hubble Space Telescope, with NASA's Spitzer, also infrared space telescope, and now with the James Webb Space Telescope. For example, a research group from the American Museum of Natural History in New York City studied the distribution of sandy clouds in brown dwarfs using archival data from the NASA Spitzer Space Telescope. They concentrated their study in type L brown dwarfs and found that the clouds are mainly concentrated in the equator. Why is this important? Well, this means that when we observe these objects, they will look different depending on their angle or the orientation toward us, but those are the same type of objects and they are just showing us a different angle. To have a better idea what this means, if we observe a brown dwarf looking at their equator, we will be observing most of the clouds and then the object will look redder. As the orientation tips toward us, away of us, they will become bluer because they will be showing us more of their polar regions, which don't have these clouds. Other observations taken in 2023 with JWST help astronomers to identify the tiniest brown dwarf ever seen, which is only 3 to 4 times the mass of Jupiter. This dwarf is located in IC 348, which is a young cluster only 5 million years old in the Perseus forming region. The team found in this cluster 3 other brown dwarfs that weigh between 3 and 8 Jupiter masses. Of the 3, the tiniest became the objects of interest because it's very difficult to explain this size with the current theoretical models for a star or planet formation. In this survey, the team also found that two brown dwarfs have an unidentified hydrocarbon signature, similar to that infrared signature that has been detected previously by NASA's Cassini mission in the atmospheres of Saturn and its moon Titan. This is the first time that a molecule like this had been detected in an object outside of our solar system. Also, another group of scientists discovered the first brown dwarf binary system ever observed by JWST. This is composed of two type white brown dwarfs separated by approximately 1 astronomical unit. Using evolutionary models, the team was able to determine the age of this system to be 1 to 5 gigayears, and also they were able to determine the masses of the primary and also of the companion. The same year, a team used HST to look for low mass binary and planetary companions for 33 nearby brown dwarfs type T and Y. They found none in their sample and therefore confirmed that actually binary or planetary companions with a wide separation that HST can resolve are rare for low mass and the coldest brown dwarfs. The previous studies indicated that only 10 to 20% of this type of dwarfs are in a multiple system. Finally, I would like to mention another recent result obtained with JWST. This is of observation of two of the coldest brown dwarfs, type Y, that a group of astronomers observed. They see that these two objects are almost identical, showing signatures of water, ammonia, methane, carbon monoxide, and carbon dioxide. However, one of them also shows methane in emission, a feature that the research team had not seen in previous observations. After, of course, verifying that this feature was real, the team associated the observed emission with something similar that they had previously detected in the auroras of Jupiter. In our solar system, the auroras are produced mainly by trapped sharp particles that are transported by the solar wind and here trapped by the magnetic field in the Earth or the magnetic field in Jupiter. However, the observed brown dwarfs are isolated and they are not close to a star, so how come they have an aurora? A possible explanation for the origin can also be found in the observations of Jupiter and Saturn. These two planets have active moons, Io in Jupiter and Enceladus in Saturn, which astronomers have associated with the production of auroras in some regions of these planets. This, however, is something that needs to be studied more to say for sure if we are looking to something similar to what we see in those planets. So after looking to all these results, we can conclude that the upcoming observations that JWST will be taking will help us understand more about these objects and resolve many mysteries that surround them, like how they form and how these relate to other objects we see in our solar system.